Hi, my name is Brandon Odell, and my group members are Bridget and Luan. This semester, we focused on creating an automated mask to help people who are disabled and who have trouble removing their mask and replacing it. So to start off, Luan is going to talk about the purpose of our mask.
Hello, my name is Ron. According to the accessibilities of wearing a face mask shield rather than a mask, it seems reasonable to conclude that the point of the mask face shield is to prevent the spread out of the virus through inhibiting the exhale rather than inhale. Which means the right means that the protection does nothing to stop the inhale. But other than that, sometimes it's very hard to limit motion people to wearing the mask all day. So we have decided to make the mask more functionally by um, mounting to server and on the exhale case that will make the mask can open or close the gate whenever the user tap on it, or it can stand rather it's inside or outside of the room to be allow it open or close the gates. For more detail of the designs, Betty gonna tell us about that next please.
Right, so yeah, we wanted the mask skills to open and close based on user taps on the accelerometer. So it would be 2 taps to open and 2 to close. We also wanted to use an ultrasonic sensor so that we could open and close the gills based on whether the user is indoor or outdoors. We also wanted a display that could show what positions the flaps are in. For our design targets, we wanted to keep it lightweight with evenly distributed weight to make it comfortable for the user to wear, and also make it easy to use so that people with limited hand motion are able to get the mask working, and also make it efficient so that the flaps can open and close instantly whenever needed. Next slide. So here's our setup. We have the sensors, picos, and breadboard on the left, and we have the mask and servos and the flaps on the right. Next slide. Here's a more detailed diagram of the hardware. So we have 2 sensors sending signals to Pico 1, and those get sent to both servos. And then the servos are also connected to Pico 2 via the breadboard. The display then receives signals from the Pico to state whether the servos are in an opened or closed position. And we also have 2 power sources for the Picos. Next slide. So for the gills on the mask, I used SolidWorks to create the frames that fit the mask, and the flaps would act as the gills as it opens and closes with the servos. The left image is an isometric view of the servo frames and the flap. The top view is the flap in a closed position, and the bottom is the flap in an open position. So yeah, these are the designs that I 3D printed so that, and they were able to fit well with the mask and the servos. Next slide.
So for the software or the programming section of this project, we decided to go with a while loop. Inside of the while loop, you can see that there is an if statement that checks if our accelerometer has been tapped. If it has been tapped, we will begin running our distance function. Our distance function to the right, you can see is what's responsible for operating our ultrasonic sensor and checking if there is a roof within 5 centimeters or outside of 5 centimeters. So this essentially is trying to check if the person is inside or outside to direct the mask towards being either in the open position or in the closed position. And then going back to the program on the left, you can see that inside that while true loop next to the distance function, there is another if statement that checks if our accelerometer has been tapped again. If it has been tapped again, then we'll break out of this loop and we'll go to the off state, which will have our flaps fixed closed. And this is to prevent from maybe one time if you're in an arena and the mask is in the open position or your ultrasonic sensors are out of range, this can automatically close the mask on it or by force. And then going into greater detail on the wire diagram or the wiring configuration of this mask, you can see there's two picos. The second pico is just for powering our servos. Our servos were running a little bit, they're getting a little fidgety when we were just running it off of one pico. So we decided to incorporate two and it worked great and they were able to be steady in one position. Really what's important about this diagram is to take note of where the signal pins or where the two signal wires for each of our sensors are located. So you can see for each of the sensors on the left side of the screen, there are blue and orange signal wires. For the OLED, these wires are connected to GPIO pins 2 and 3. GPIO pins 2 and 3 are unique because are special because they can send out an I2C signal, and this allows us to operate our OLED. And then the ultrasonic sensor is connected to pins 6 and 7. Pin 6 and 7 operate based off of a pulse width modulated signal, and you can see them in this diagram here. And then if we go back to this diagram, you can see that the accelerometer is connected to GPIO pins 8 and 9, which you can see, or I'm sorry, 11 and 12. For GPIO pins 8 and 9, but they're pins 11 and 12 on this diagram. And those are also pulse width modulated signals or input receptors. And then the servos themselves are actually connected to GPIO pins 21 and 22, which you can see on the right side of the Pico here, which actually send out GPI or pulse width modulated signals to the servos as well. Here's our demonstration. And then to Luan for our project outcome.
Overall, the automatic mask work very well. All functions are on track. The mask could properly send whatever is inside or outside by itself, and even it could not open the exhale gates. Even the user try to make it. The power display and sensor servo work as expected. Mm. However, in an actual product, to be more helpful to the limited motion one, we shall mount the people on the wheelchair and wireless them with a sensor and server. And the tap control should be on the mat to make them more convenient. At the end of the day, the project combine that's what we learned from every 106, such as Pico, motor, server, and display. And that's make the world's mechanism more valuable by becoming mechatronic. Please. Next, please. So what I learned from the project is personally, so I learned a lot because I learned about the servo display and sensor, even motors on the project. But the most important is about the help from my partner because they help me to understand the while loop, the global value, how it's interface with the main loop, and what did you learn from this project, Brandon?
Yeah, so from this project, I learned all the different signals that can be received and sent by the Pico. And I also learned about the limitations of pulse width modulated signaling as we ran into complications in our state machine design. And we were actually not able to continue on with that one. Then I also learned the limitation of the number of attachments the Pico can actually have. So in a real life application, more likely the Pico would not be used to power the sensors and the actuators. It would just be used to receive the signal and send signals. What about you, Bridget? What did you learn?
So I've never worked with a Pico before this project. So I was able to learn how to interface different sensors, display, and servos with the Pico and the specific groves that they needed to be connected to. For example, the display needed to be connected to certain groves that were connected to I2C, SCL, and SDA to be able to receive signals. I was also able to practice designing parts to be 3D printed so that it can fit snugly with the mask and the servos. And that concludes our project.